Okay, guys, rather than going through the PowerPoint for this, I thought I'd just do it as a regular write it on the board kind of thing, and this is the closest I can come. So we need a plan when it comes to stoichiometry. How are we going to get from what they've given me in the problem to what I want to find? And this will be similar or seem, you should recall this from our earlier chapters. And we're just building another layer on this. So for stoichiometry, the first thing you need to do is write out and balance the equation. And we've done that. We've also done things where you have to do some dimensional analysis. We're still going to use those skills. And you start by writing out what are you given and what do you want to find. And you need your conversion factors. This sounds familiar, I am sure. And the conversion factors you're going to need are three things. The first one will be the molar mass of what you're given. The second one is the mole to mole ratio of what you're given to what you want to find. And the last one is the molar mass of what you want to find. So you're going to need your periodic table. If you don't have one, I will post it so that you can use the one that I use so we're all using the same numbers. You don't have to print it out, but it might be easier if you did, but not necessary. After you have your conversion factors, you're going to set everything up using dimensional analysis, and you're going to make the units cancel, and you should come out with whatever it is you want to find in that unit. Lastly, or the last two things, is you're going to have an unrounded number. I want to see it. You should know how many significant figures you need. I would determine that as soon as I'm given something. And right next to the given, I would write my significant figures. So then I would have one additional number in step 5, and then step 6 is to round it to the correct number of sig figs. So let's work through an example. And then I'm going to rely on you to ask me questions. So here's our question. Calculate the number of grams in NH3 produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. The balanced equation is. So I've given you the balanced equation. That's our first step. So it's balanced, and you'll have to remember our 7 diatomic elements. It's hydrogen, then you start with element 7 and you make a 7. So I'm going to just write them up here so that you recall them. H2, N2, O2, F2, Cl2, Br2, and lastly I2. So the next step after balance the equation is, what am I given? And I am given that I have 5.40 grams of H2. Right now I'm going to write that my SF equal 3. So now what do I want to find? It says calculate the number of grams of NH3. So I want grams of NH3. That's my question. Now my conversions. So we'll need a periodic table, but you'll just have to trust me that I know these numbers. Hydrogen is 1.008. Nitrogen is 14.01. So I need to first know the molar mass of H2. And that's going to equal 2 times 1.008, which when I get out my calculator, 1.008 times 2 equals 2.016. And that's grams of H2 for 1 mole of H2. And I could write that either this way or flip it over, whatever I need. So there's my first conversion. My second conversion, I need a mole to mole ratio of what I'm given to what I want to find. And so I'm given 383 moles of H2 for 2 moles NH3. Or I could write it 2 moles NH3 to 3 moles of H2. And my last conversion factor is the molar mass for NH3. So N, I have one of those times 14.01. Hydrogen, I have two of those times 1.008. And so my calculator, 1.008 times 3 plus 14.01 equals 17.034 grams of NH3 equal 1 mole NH3. And so there are two ways I could write that as a ratio as well. So now we're going to use our line. We're going to start here with what we're given, which is our 5.40 grams H2. And every spot has to have a number, a unit, and a substance. If it does not, it will be wrong, even if you get the right answer. So, since I have grams H2 here, I need grams of H2 down here. So 2.016 grams of H2 for 1 mole of H2. Still a number, a unit, a substance. Grams of H2 cancel. Now I'm going to use my conversion factor. I've got moles of H3 here, so I'm going to need to use this one and not this one. So 3 moles of H2 for 2 moles NH3. Moles of H2 cancel. And so I've used this, now I'm going to use this. And I need moles to cancel, so this goes on the bottom. 1 mole NH3 for 17.034 grams NH3. And moles of NH3 cancel. So I'm telling you this is the best way. You can do what you want because obviously I can't see you. But do this in one calculation. You start with this number and you work from left to right. If it's below the line, divide. If it's above the line, multiply. And if it's 1, ignore it. So I'm going to pull this up so you can see both the problem and what I'm doing in the calculator. So I'm going to start with 5.40. Since this is in the denominator, I'm going to hit divide by 2.016. I'm going to hit times 2, divide by 3, and then I'm going to hit times 17.034 equals. And so I decided back up here that I have 3 significant figures, so I'm going to write down 4 here. So that'd be 30.41. I do not round, I just write the first 4 digits. That's going to be grams of NH3. Since I have 3 significant figures, I'm going to round to this position. The one tells me I round off, so it's going to be 30.4 grams. NH3 is my final answer. So, I hope this is helpful for you. I will be posting more questions and solutions as needed. This is something I really need your feedback on, so you have to tell me how it's going. Thanks for watching. Bye.